Oh, the biggest piece of advice I could give is to reach out to get help. It's very difficult to start working in 3D, and so it's very important to reach out to your resources. A lot of companies like Corning, we have field application scientists like myself that you can reach out to and ask questions of. So definitely don't be afraid to ask for help.
Try to convey patience. And the reason for that is that it takes a little while to understand how to grow them, how to stain them. You have to do a lot of optimization. It's not just putting 80% confluent 2D culture, throwing drugs on them and letting them go. And I really think that you have to walk customers or graduate students, postdocs, whoever you're looking at, the whole process, because you just have, it's a different way of doing things. And if you can use the right tools to generate, homogeneous spheroids or organoids, I think that's a big part of the game. But again, to me, it's just walking them, talking about optimization, and once they get used to it and see the kind of results they get, they don't want to go back to 2D.
Just start reading, seeing what other folks are doing, looking at the tools out there, and always sort of asking yourself, what kind of question am I trying to answer? Sometimes we're eager to make things more complex than what's necessary, and sometimes that complexity adds value. But we always have to weigh the complexity with cost and time and all these other factors in the lab. So the better understanding we can have about the questions we're trying to answer, the better chance we're going to have at picking the right model.
So any advice I would give to someone starting out in doing 3D biology and 3D research is really probably similar to what I would say to starting any project. Obviously do your background research in literature reviews. Challenge what I think is somewhat biology lore. So just because someone says you have to do it a certain way doesn't mean that that is the way that will work. I would say be persistent. And just because if you're just, for example, using tumor biology as your initial starting point and you get a raw tumor, it takes time. It takes time for these cells to proliferate and grow and do what you need to do. But stay after it, and generally speaking, those things will take off and you'll find the paths around it. So it may take weeks or months, but I think with good persistence and keeping your eye on the prize, you'll get there.
Think outside the box. I think I say that to my scientists all the time. Think outside the box, because most of these scientists have gone through training and gone through their PhD programs working with 2D models. So you have to think a little bit differently, not only in terms of how you manufacture these 3D models, but also how do you maintain it, how do you analyze it, how do you assess some of the assays that you've previously used with 2D, how do you assess it with a 3D model. So I think it requires a completely novel way of thinking in terms of tissues are concerned.
For scientists who are just getting started in this field, I would say it's like the Wild West. There's a lot of opportunities out there. And think carefully before you dive in, see what those opportunities are, and then really dive in and go after them, because anything that you can imagine, I think can be done. And you could be very surprised along the way as well at some of the opportunities that come across your dish. When you give stem cells a chance to change into different types of structures, sometimes they'll surprise you, and you've got to be prepared for that as well. So dive in. It's a labor of love. There's going to be a lot of work. There's going to be some disappointments along the way, but if you stay the course, I think you'll find that inspiration is rewarded.